Today we're going to look at integration by parts. So up until now we've seen two integration techniques, right? We've seen the reverse power rule that we use for integrals such as this, the integral of x squared dx, and we'll say that we can raise the power by 1 and then divide by that new power, and we'll solve that this integral is equal to x cubed over 3 plus c, right? And then we've seen use substitution, which we'll use for integrals such as this. Say we're finding the integral of sine of x cosine x dx. We'll assign one part of our integral to the variable u and another to du. And then when we do that, we'll plug u and du back into our integral and find that it's much simpler to solve. So I wonder, how would we solve this integral? X times sine of x dx. We're clearly not going to use the reverse power rule, so let's try use substitution. That's our only other option, right? So we'll assign x to u, therefore du will be equal to dx. Now let's substitute this into our equation. We'll get the integral of u times the sine of u du. And that has not helped us at all. We have simply changed the letter of our variable. We haven't moved forward at all. So we need to use this new integration by parts formula. So let's start to derive this formula. Let's look at the product rule, right? This is the first step to deriving the formula for integration by parts. We know that if we have two functions, f and g, the derivative will be equal to f prime times g plus f times g prime, right? The next step to deriving our formula is to take the integral of both sides of this equation. Now on the left side, the integral and derivative cancel each other out, so we'll just be left with f times g. And on the right side, I just want to split our integral into two integrals, so we'll have the integral of f prime g dx plus the integral of f g prime dx. And now I just want to rearrange our formula just a little bit, and we'll say that the integral of f g prime dx, so this is originally from the right side of our equation, is equal to f times g minus the integral of f prime g dx. All I did was rearrange our formula a little bit. Now I want to get rid of all these f primes, g prime dx's. I just want to make it simple. Let's use two letters, u and v. We'll say that u is equal to our f of x and v is equal to our g of x. And then we also want du and dv. So these will be equal to f prime of x dx and dv will be equal to g prime of x dx. And let's substitute these into our final, so we can get our final formula for integration by parts. And we'll find that what we get is the integral of u dv is equal to uv minus the integral of v du. So this doesn't make much sense right now. It probably doesn't. So what we're going to do is try our integral again, and hopefully when we put this into practice, it'll make a little bit more sense. So our integral is the integral of x times sine of x dx. Let's use our integration by parts formula, right? Let's assign and say that u is equal to x, right? And dv is equal to sine of x dx. V would then be equal to negative cosine x, and du would be equal to just dx. Let's plug this into our integration by parts formula. So we know that the integral of u dv is going to be equal to u times v, so that is just going to be negative x times cosine x minus the integral of v du. So we said that the v is equal to negative cosine of x and du is just dx. And when we take the integral of that, when we evaluate the integral, we see that we have this is equal to negative x cosine x, and that integral is going to be equal to negative sine of x. So if we subtract negative sine of x, we'll just be adding sine of x. And since it's an indefinite integral, we have plus c. And that is our answer. That is how we do integration by parts. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.